statement, imperative statement, every time we will require the location counter. Okay, so this is the difference between imperative statement and assembler directive. Okay, I'm talking about the difference between imperative statement. So you include it with the declaration part also. You can include it with the declaration part also, and the assembler directive. Okay, now while discussing about this declaration statement, what kind of values are there involved in declaration part? Okay, one of the value, it might be the constant value. Okay, here we can have constant value, or another value, it might be the literal value. So whenever we are solving the pass-1 assembler program, we will require two kinds of table. One of the table, it will go for the constant value, and we will store or create a data structure known as symbol table. And another one is what? Another one is the literal. So for that purpose, we will create literal table. Okay, literal table in the sense it is related with the data structure. Okay, so for handling the declaration statement, we are having two forms. It might be a constant value or it might be a literal value. Literal value in the sense when we are having, I will just add literal value equal to 5. Okay, with quote. This is known as the literal value. And what about symbol value? Symbol value you can specify like 1. 1 is the symbol value. So we will require two separate tables to store whatever symbols or literals are available in our assembly language program. Okay. Now, after that, let's move on to the assembler directive. We will talk about in detail what is assembler directive. After declaration statement. So we have seen imperative, we have seen declaration statement. Now talk about the assembler directive. Okay, so what is assembler directive? Just look at that table. You have taken the screenshot. This is the assembler directive. Start, end, origin, EQU, and LTORG. So what is start? We will see the syntax for each and every one. So what is start? Start is nothing but the instruction which will tell the location counter value for the next instruction. Okay. So what start consists of? Start consists of some constant value. Why constant? Because it is address. Right. So example is what? Example will be like this. This is the syntax and start 500. Okay. So next instruction. Okay, not the same instruction. Next instruction will start from the 500. So let me show you start 101. Okay, so what is the location counter of read? Location counter of read is 101. Are you getting me? Yes. Are you getting me, everyone?
Yes, ma'am.
Okay, so this is the start instruction. Now what is the next one? First one is start. Next one is end. So you already know, no need to talk about end. What is end? End and some operand specification. It will end the process. Okay, so what is syntax of end? Syntax of end will be like this. Here we can have the operand specification. Okay, operand specification. So no need to have example. Example if you want, you just go with end. So let me show you here. End. Okay, nothing is there. So after end, let's move on to the important assembler directive, that is origin. Third one is origin. So what is origin? Origin is nothing but it will tell you the origin of the instruction, next instruction. Just like start. Start will start your execution and it will assign the location counter or address for the next instruction. What about origin? Origin might be in somewhere in your program. Okay, though you are starting from 101, but you may encounter some origin statement within your program, and at the same time it will replace address of the start, okay, or the respective number with the origin number. Okay, the name indicates the same thing. What is origin? Origin is the operand specification. It will assign the address to the next instruction, just like start. So what is the syntax of origin? So syntax of origin is like this. So syntax, and here you have to specify the address. Okay, I'm writing in short, address specification. For example, example is origin 400, constant value. Okay, because address is the constant value. So what this example will do, will set location counter, okay, to 400 for the next instruction. Okay, 400 memory location. So this is the thing. Origin means it will set the location counter for the particular thing. So you may encounter some other example also. Origin, some symbol. Symbol is like again is the symbol. Okay. Again plus 4. Okay, this is the simple format of origin, or you may have this kind of format also. Machine code is origin and again plus 4. So what is the value of the location counter? Say for example, again it will be at, here I am just writing in rough, again memory location is consider as 410. Okay, 410 is the again location. Now what is the origin of the next instruction? So origin of the next instruction is 410 plus 4. Okay, so it is 414. Okay, you have to add this constant value to the address of the symbol. And where you are getting it? You are getting it in the symbol table. Okay, when we will talk about symbol table, literal table, you will have the idea. It consists of the name of the symbol and address specified to it. Okay, so this is origin. Now next instruction is what? EQU. EQ means equate. Okay, EQU instruction. So EQ is again a similar directive. What is the syntax of EQU? Here you may have a symbol. Okay, then here you can you are having actual code EQU equate to some address specification. Okay, so some address is given here, and the address of this operand will be assigned to this symbol. Okay, EQ means it is equivalent to this symbol. So what you have to do when you are solving the examples, if EQ statement is encountered somewhere in your program, then whatever address of this operand 2 is there, you have to assign the same address to this symbol. Okay, are you getting me? So what is EQ? This is the directive which can associate the symbol with the address specification. Okay, so let me take one example. Suppose symbol is given here, result. Okay,